Grubhub robot's reaction to a person. First, it receives a location to travel to based upon a GPS signal and begins its journey. Next, the bot locates the person while on its path and compares their two locations. It stops, slows down, or reroutes based upon this input. It has an input of the force generated by its rotational motion, which is based upon the Grubhub's position, velocity, and acceleration. Based upon this, its output is the robot's new velocity.
Focused on in this project is the Starship Robots autonomous navigation and obstacle avoidance system. This system is continuous, as the robot consistently checks for obstacles in its way and continuously adjusts its speed, acceleration, and heading to stay on course. Specific system, the components are perception and recognition, decision-making and planning, and motion control.
We are operating with 4 coordinate frames. The ECEF is our fixed frame, and then we have the E and U frame, which determines the east and north frames for the robot, and then the robot has its own frame, and then the obstacle has its own frame, and they all interact together through a rotation matrix. Here are the system features of the robot. The main thing is that it weighs 83 pounds, and then it can hold up to 22.
U is an input, and it is the force generated by the Grubhub robot's motion. It has the equations of motion below. Furthermore, the location input can be decomposed into x, y, and theta, where x is left and right with respect to the robot, y is forward and backwards with respect to the robot, and theta is the angle of deflection between the motion of the robot and north as defined by the E and U frame. All of the variables and components to be analyzed within the robot's equation of motion are shown. Below is the state space representation of the system, where the inputs are x, y, theta, and the velocity. Because the system is nonlinear,
As a whole is made up of multiple control systems that are both positive and negative feedback loops. The specific system that we are analyzing is a negative feedback loop. It is a negative feedback loop because it takes in information, the desired speed and location, and then does something with that. And the sensor takes in the person's distance, calculates it, and then predicts its behavior, and based off of that prediction, the controller decides how it wants to proceed.
The PID controller is used to regulate the wheel speed and keep the robot's motion stable. It minimizes the error between actual and target speed and ensures precise movement and reliable stop. The robot receives a start and endpoint and uses GPS to compute a desired path, computing target speed and heading along this path. A distance sensor feeds a conditional block that decides whether the robot should continue or stop if there is an obstacle. If the path is free, the controller converts the desired speed and heading to target left and right wheel speeds. The PID control loop then compares these target wheel speeds with the measured speeds and adjusts the motor command so the bot follows the desired trajectory.
Is the Starship Robots autonomous navigation and obstacle avoidance system.